afternoon all. I am Yogesh Jangle, working as Assistant Professor in Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today we are going to discuss about geometrical dimensioning and tolerances. Next part. After this session, students will be able to understand GD&T symbols on production drawing. Students will be able to read industrial drawing which is used in the industries. The content covered today: 14 symbols of GD&T, angularity, perpendicularity and parallelism. This slide we already discussed about in the last session. What is GD&T and what is the need of GD&T? Just go through the slide for some time. In 14 symbols for the last lecture, we discussed regarding these form tolerances: straightness, flatness, circularity and cylindricity. All these are the form tolerances which maintain the form or shape of any of the feature within a tolerance zone. Now today we are going to discuss about angularity, perpendicularity and parallelism. These are all orientation tolerances. And we can say the form tolerances are individual features. There is no need of a reference or a datum to indicate these tolerances for a feature on a drawing. But orientation tolerances are referenced tolerances which is indicated with the help of datums. The feature to be tolerance is indicated with the help of datums. Okay. Now in this case, the first orientation tolerance, that is angularity. Angularity is the condition of surface or axis or a center plane at a specified angle. Okay. If any of the edge, or I can say feature, which is in inclined or slant edges generally, these are shown with the help of angularity symbols. Okay. Apart from parallel and perpendicular to a datum plane or a datum axis, this orientation angularity symbol is shown for slant edges. What is the meaning? In this case, it is nothing but a leader line, as we know, and this is a feature control frame. The first box indicates a symbol, second box indicates a tolerance, and third box indicates datum. As I told you, all orientation tolerance are featured basically with the help of tolerances. Simply it means the slant edge is within a tolerance of 0.02 with respect to the datum surface. This is the indication we discussed for the last lecture. The lower surface is the datum over here. This slant edge is inclined within a tolerance of 0.02 with respect to datum A. And this 0.02 is nothing but it is every point on the selected feature should lie within a band, tolerance band of 0.02, which is angled to the datum plane A. These two lines indicated over here within a tolerance of 0.02. Now, how it is going to be inspected? The part is set up at the nominal angle using a gauge blocks. Generally, gauge blocks are used. Dial gauge is fixed parallel to the horizontal and run across the surface. The full indicator reading should be lesser than 0.1 or 0.02 as per this is for this case, basically 0.1 case. Okay. The full indicator reading should be lesser than 0.1 to validate as a good part or angular part. Now nowadays, okay, angle protector is also used to measure the angle of slant edges. Now basically the tolerances are given in terms of, I can say, mm or dimensions. Okay. For this case you can see This slant edge must be angular within a tolerance of 0.3. With respect to, there are three references used for this feature to be indicated with the angularity tolerance. Okay. Now, point 0.3 is nothing but a tolerance zone. Simply, it is nothing but this in this zone, the slant edge must be lies. But how can we measure? While measuring, generally angles are provided in the degrees. For that conversion, we require to do this calculation. This is the basic, say, mathematical calculations. Tan x 0.3, 0.3 is the tolerance zone over here, and divided by 40 is total length of the slant edge over here. Total length of the slant edge. So we will get the exact angle over here. So that we can say angle range must be within a tolerance of 0.42 degree. This is the meaning. Okay. So the case study, generally angularity is generally provided to the slant edges as we discussed. In this case, these two slant edges must be in a tolerance of 0.1 with respect to datum A. Where is the datum A? Datum A is nothing but a bottom surface over here. Okay. Now this 2x indicates there are two, I can say, surfaces which are having a slant edges, Okay. So in this case, angularity orientation is thus critical for assembly for this purpose, so that we have to maintain the angularity within a tolerance only, because if that feature is going to assemble to other feature, in this case, these two feature must be tolerance with the form as well as in dimension as well. Okay. Next is nothing but a perpendicularity. Perpendicularity is the condition of a surface or axis or a center plate at 90 degree to the datum plane. Here, we are restricting the angle to the 90 degree. We are restricting the angle to the 90 degree in this case. Okay. The lower surface over here is nothing but a datum surface, and this surface is nothing but a tolerance surface or a feature. Again, first box indicates tolerance, symbol. Second box indicates a tolerance. Third box indicates a datum. Just wanted to highlight over here, in orientation tolerances, all orientation tolerances, the reference must be there, reference or datum must be there, so that we can relate it with each other. Okay. In this case, for the meaning of this basically perpendicularity, again, every point on the selected surface should lie within a band of 0.02, which is perpendicular to the datum. This band is nothing but a tolerance band basically. Okay. This is the meaning, simple. We'll move further. It can be measured with the help of, I can say, devices such just like as a surface plate, gauge block, which is exactly perpendicular. Okay, and this is the part to be measured on. This is nothing but a specific feature to be measured the perpendicular. If there is a gap, it can be measured with the help of gauge wire, which is equal to the tolerance zone. Okay, this is the regular method. We can insert the wire over here and we can measure at different position whether it is perpendicular or not. If it is not exactly perpendicular, then it can be rejected. Next is nothing but a parallelism. Parallelism is the condition of surface which is equidistant at all the points to the datum. Okay, we can say the lower surface must be parallel to the upper surface. Okay, or upper surface must be parallel to the lower surface. In this case, the lower surface becomes your datum surface and upper surface becomes your tolerance feature. Now, the upper surface is nothing but tolerance feature and the lower surface is your datum feature. Simply, first box indicates a symbol, parallelism symbol. This is a regular symbol. Just remember this all the time, because in most of the interviews it is asked what is the symbol for parallelism. Okay, it is tolerance within a 0.02. Again, the meaning is same. The feature, upper feature must be tolerance within a tolerance of, must be parallel within a tolerance of 0.02 with respect to lower surface A. This is the meaning of this parallelism. We'll move further. How it is to be inspected again? The part is rested on the datum feature or surface plate. Surface plate is simulated datum. A dial indicator is run across controlled surface area on all surface area over here. If it is exceeded, it again can be not accepted. This is the regular method for checking the parallelism. Now we'll see one case over here, one example which includes most of the orientation tolerances. Okay, you can see this is a perpendicularity, this is a parallelism over here. Again, it is a perpendicularity over here, flatness provided over here. Okay, what is the meaning of each and every symbol? We can see first one, flatness of a central of a plane with a tolerance of 0.05. It should be maintained with a 0.05. First case over here. Axis of hole is perpendicular to the diametrical tolerance with respect to A. Most of, as I told, most of orientation feature are tolerance with respect to datum features. Angularity of a slant edge is maintained within a tolerance of 0.1 with respect to A, B and C. There are three, I can say, datum A, datum B and datum C. The slant edge must be angular within this tolerance zone, and with these three features, datum features. So likewise, there are some more examples as well for your understanding. The second example over here, this is perpendicularity. This slant edge must be angular within a tolerance of 0.1 with respect to A and B. A is this datum, this circle indicated as a datum over here, or I can say axis indicated as a datum over here, and second feature is this slot indicated as a datum feature over here. So what is the difference between parallelism versus flatness? The basic difference you can understand over here, parallelism is orientation tolerance which is given with a datum feature. There is no need of datum feature. This is the basic difference between parallelism and flatness. Again, the slant edge may be flat, or we cannot say it is exactly parallel. I repeat my statement. The slant edge over here, that individual slant edge, it may be flat, but it is not parallel to each other. Simply. That is the meaning. You can understand about this. So for these concepts, I referred ASME standard 14.5 2009 dimensioning and tolerances, machine drawing by N.D. Bhatt. Okay. Thank you all for listening patience.